So let's look at the x and y intercepts for linear equations. Okay, so let's start. Here's a graph, and let's look at this graph, and let's find out what is the y-intercept. So I got to look at my y-axis and my vertical axis here. Okay, and the y-intercept is simply the point where it crosses that axis. So it's labeled with B, but I actually need to get a coordinate point. So that's 0, 0, 3. Right? I'm not going to the left or right, so my first value is 0, but I went up 3 spaces. Okay. So if I'm going to look for the y-coordinate or the y-intercept for this one, go down my y-axis till I hit the graph, and the y-axis is this point A, and that's the point 0, -2, because I went down 2 spaces. Okay. So we're just looking at y-intercepts. All right, here's another graph. There's my y-axis. We intersect right here at this point A, and that is the point 0, 5, because all we did was go up 5 spaces. So what is true about the y-intercept of any graph? So here's the 3 y-intercepts that we just looked at in the 3 different graphs, and we're looking for what is always true, and you can see here that the x value is 0. If I'm on the y-axis, my x value is 0, or vice versa. Okay, so we can use this understanding to find a y-intercept when it's not so obvious. So, for example here, what is the y-intercept of the graph? I purposely do not have it visually, right? I can't see it. Okay, I ran out of room, and sometimes it could be really big or small or hard to find. But I do have the equation of the line. Okay, so knowing what I do know, that the y-intercept is the point where the x value is 0, I'm just going to make the x 0, so I can plug in a 0 right here, right? And 2 times 0 is 0, and y equals 11. Okay, so that is my y-intercept right there. Okay, so the y-intercept is the point 0, 1, because technically it is a point. Okay, my x value was 0, I made that happen, and then I found out the y was 11. I basically found one point on the graph, and in particular, it was the y-intercept. Okay, so here's another equation. So what is the y-intercept of the graph of this function? Okay, so remembering what I know, the y-intercept is the point where the x is 0. So make the x value 0. Substitute in a 0 for the x. 2 times 0 is 0, right? Then I got to get the y all by itself and isolate the y. So I'll divide by -3, and y equals -6. So the y-intercept is the point 0, -6. So now let's switch and let's look at the x-intercepts. So if I look at this one, it's point A is my x-intercept, and that is the point -4, 0, because all I did was go to the left 4 spaces, did not go up or down. Okay, so what about the x-intercept on this one? And it might be a little bit confusing because it's actually not labeled, but it's actually that point right there, and it's the point 2, 0. Okay, we're looking for the x-intercept. Okay, so it's 2, 0. All right, so what is true about the x-intercept of any graph? So here's the 2 x-intercepts that we just had, looking for any consistency here, and it is the y value is always 0. Okay, so what is the x-intercept of the graph of the function? So now we know the x-intercept is when the y value is 0, so I will substitute in a 0 for the y. Okay, 2 minus 3 times 0, which is 0. 0 times -3 is 0. Divide both sides by 2, and x equals 9. Okay. So the x-intercept is the point 9, 0. Because it's an x-intercept, not a y-intercept. All right, so here's the same equation. Let's graph it. But we're not going to use y equals mx plus b. We're going to graph it using the x and y intercepts. Because if you remember, a linear line, a straight line, only needs 2 points. So we can find the x and the y. So we found out earlier that the x-intercept was 9, 0, which is right there. We just figured out in the last slide that the x-intercept was 0, -6. Sorry, the y-intercept was x 0, -6. Okay, few slides back. And so now we have an x-intercept, which is 9, 0. We have a y-intercept, which is 0, -6. Connect the dots, and it is graphed.